Here we'll have the answer for week 2's problems on profit and loss. Okay, the first question. The side of a square is increased by 20%. Its area will increase by... Now, in order to work out this question, we need to assume that as one side length increases, the other side lengths also increase to make sure that the square maintains its squaredness. You can see here that I have two different squares, a white and a blue square. Now, these diagrams aren't to scale, but if I assume that the white square is my original square and the blue my second square. Now, we're going to assume that the length of the first square, which is my original square, has sides of x, and I'm going to write them in here now. If I know that each side length is increased by 20% in its second square, I can label that as x multiplied by 1.2. I can now try and work out the areas of each square to work out what the difference between them is, and that will tell me how much it increased by. If I look at the first square and know that area equals length times width, I'll have area being x multiplied by x, or x squared. And if I look at the area of my second square, I'll have area equals 1.2 times x times 1.2 times x. I can obviously group my like terms, so I'll have x squared times 1.2 squared, which will give me 1.44 x squared. You can clearly see that the value of my larger square is 0.44 bigger, or 44 hundredths. Therefore, the sides increase by 0.44 over 1 times by 100, which is going to give me 44%. And that's the figure I'm going to put up here. The square has increased by a value of 44%. And now for question 2. A shop has all the prices of all its goods slashed by 10%. To boost sales further, it slashes the prices by 10% again. In the third adjustment, it marks the prices up by 20%. What is the final price in percentage compared to the original price? If we let the original price of the goods, of all the goods, be equal to P, we can then work out what the price would be after the first price cut. If all of the goods have been slashed by 10%, that means they're at 90% of their original value, or 0.9p. If we need to make a second price cut from 0.9p, and we know that that is also 10%, we can multiply 0.9 times 0.9, or 90% of that value. Therefore, we will end up with a value of 0.81p. If in the third price adjustment I need to add 20% onto the current price that I have, I can then multiply 0.81p, which is what I found after the second price cut, and multiply that by 1.2, the additional 20%. This should leave me with a value of 0.972p. I can then see that my percentage difference from the original price to now is 97.2%. The price of an item in a shop has been marked up by 15%. By what percentage must it be discounted to return it to its original price? Let's let the price of the item be equal to P. Now we know that the markup price is going to be 15% larger than that, or 1.15p. In order to work out the amount that we need to discount it, we need to know what our markup price is, or 15%, and we need to divide it by our total price. Okay, so 0.15 over 1.15. This value of 0.15 divided by 1.15 is equal to 0.130434788, and I've put a few dots in there to signify that this number continues. Now, if we wanted to, we could have rounded this number off to the nearest amount. The more digits I include, the more accurate my answer will be. Therefore, in percentage terms, we're actually discounting it by 13.043478% to 6 decimal places. I've calculated this by multiplying my previous figure by 100. On the right hand side, you can see that I've now included a worked example, just to show you that this actually works. If we assume that the price was $10, the markup price would therefore be $11.50. If I've multiplied my $11.50 by my percentage discount, in this case I kept it to the large number of decimal places, you'll see the answer there. As I subtract it away, I'm left back with $10. Now it might look slightly out by the 6th, 7th, 8th decimal place. That is because I have rounded it previously. If I wanted to show that it was exactly equal to 10, I could have also done 1, take away my 13.043478%, and multiplied my approximately 87% by my number of 1150. Shop A imported a sofa set at a price of 10% lower than what Shop B paid for it. The two shops marked their selling price at a profit margin of 20% and 15% respectively. The selling price of Shop A was $133 lower than that of Shop B. What was the cost price, therefore, that Shop A paid for it? Let's let the cost price of Shop B equal P. Therefore, we know the cost price of Shop A was 0.9p, given that it's 10% lower than what Shop B paid for it. Now, in order to work out Shop A's selling price, we can start with our 0.9p times by the profit that they're making. Now, we know that they're making 20%, therefore we multiply it by 1.2, and the Shop A selling price is 1.08 multiplied by P. Shop B's selling price is P multiplied by their 15% profit, or 1.15. Therefore, their selling price is 1.15 multiplied by P. Now we know from the question that Shop B's selling price take away Shop A's selling price equals $133. Therefore, if I now substitute in my values of 1.15p take away 1.08p, I've got $133. This leaves me with 0.07p equaling $133. In order to now work out what the value of p was, I need to divide both sides of my equation by 0.07, which you can see that I've done in orange. This leaves me with the value of p being equal to $1,900. Now, that's only the cost price for Shop B. I was interested for this question in what the cost price was for Shop A. Therefore, I'm going to need to multiply my figure of $1,900, which is my cost price for Shop B's sofa, by 0.9, and this will give me the cost price for Shop A. If I now do this calculation, you will see that the cost price for Shop A is equal to $1,710. The price of a winter coat increased by 5% in 2009 compared to 2008. In 2010, it increased further by another 10% compared to 2009. The price was finally reduced by 15% in 2011 compared to 2010. What was the percentage of the cost in 2011 compared to 2008? We can label the price of the winter coat in 2008 W. Now, given that we know that it is 5% greater in 2009, we can label that 1.05 times W, or 1.05 W. Now, to work out the 2010 price, we can multiply our 2009 price of 1.05 W by 1.1, because I've added 10%. Therefore, 110%, or 1.1. When I do this calculation, I end up with 1.155 W. To work out the 2011 price, I can multiply my 2010 price of 1.155 W by 0.85, because I've now taken off 15%. So 100 minus 15 equaling 0.85. This will leave me with 0.98175W. If I want to convert this to a percentage, I can do so by multiplying it by 100. That means that my 2011 price will be 98.175% of the price compared to 2008. So the winter coat is now cheaper than it was in 2008. So there you have it, 98.175%. A laptop is sold at 80% of its selling price, and the shop still makes a profit of 20%. Find the selling price if the purchase price is $2,400. If we let the selling price equal S, we know that we've got 80% of the selling price, or 0.8, and that's equal to a profit of 20%, which is 1.2, or 100 plus 20%. Now we need to multiply that by our purchase price, because we know we're making a 20% profit on whatever we paid for it. So in this case, our purchase price was $2,400. Therefore, 0.8S is equal to 1.2 times 2,400. We now have 0.8S equaling $2,880. We can divide each side of these equations by 0.8 to find the value for S. We could also try working out 10% of 2,880 by dividing by 8 and then multiplying that by number by 10 to reach 100%. I'm going to just divide it by 0.8 to get my full value of S. If I divide 2,400 by 0.8, I'll end up with $3,600. Therefore, the regular selling price of this laptop is $3,600. And that's the final question for this week's lot of extension homework.